Hello everyone. Today I will introduce our works on composition of the effects of attention mechanism on translation tests of different lengths of ambiguous words. First, in recent years, attention mechanism has been widely used in various neural-machine translation tests. Our works focus on the performance of attention mechanism in translation tests with ambiguous words test in different text lengths, trying to find out the influence of the context marker on attention mechanism in translation tests. We hypothesize that the attention mechanism has similar performance when translating text of different lengths. However, the experimental results shows that the performance of neural machine translation models using attention mechanism will gradually decline with the increase of text lengths in the translation text with ambiguous words. We used two pre-training neural machine translation models, Google T5 model and Machine MT model, as our experimental objects and trained them on same training set. We used the dataset from Contra WSD with ambiguous words as a composition with the ordinary all-pass dataset. All blue scores were evaluated by star blue. After filtering ambiguous word, 5,000 test sentences are left in abbreviation corpus. At the same time, the same amount of data is randomly sampled from all-pass dataset, and this test data are divided into different groups according to the test length. And then, we use Blue Index to evaluate the performance of NMT models on data with significant difference in test length. Left table shows that the performance of two NMT models for long text and short text processing on two datasets. No matter T5 or Machine MT, there is no obvious difference in the processing of long text and short text in ordinary all-pass dataset. However, on the Contra dataset with ambiguous words, the performance of both two models in short text is significantly higher than that in long text. Therefore, compared with the long text, the two models perform better in short text translation test with ambiguous word. In order to further verify the relationship between the text length and NMT models with attention mechanism in translation performance, we further split the dataset and get the trend shown in the right figure. Next, we want to explore the details of the attention weights while dealing with ambiguous words. Due to different text lengths, we use the residual coefficient to express the performance of attention weights matrix, where n is the length of the text, E is the diagonal matrix of size n, and Wi is the attention weight matrix of layer I. The larger the residual coefficient R is, the less attention weight is. Then we test the variation trend of R on the different text lengths on the ambiguous dataset, and get the result shown in the following figure. The result shows that with the increase of the text length, the performance of the attention weight gradually decreases. We just confirm that the performance trend of the NMT models. It is significant to understand the performance difference of attention mechanism on different scalar text dataset, which may indicate the potential optimization direction of attention mechanism in such tests. We hope that our future work can continue to improve our understanding of deep-seated principle of attention mechanism in NMT models, analyze the details of attention weight in NMT models when dealing with billions-word tests, and explore how to improve the translation effect of NMT models in different scalar tests since disambiguation tests. That's all I have to say. Thank you for your time.